we're going to work with solving equations that have variables on both sides of the equation. So let's take a look at this one right here. This is a y, and it's on the left side of the equal sign, and this is also a y, and it's on the right side of the equal sign. And we want to go solve and find out what in the world this y is. Um, in order to do that, basically what we do is we get all of the variables to one side of the equation. So this is a 3y. We need to go ahead and subtract 3y. That's how we would do it. So we just draw a line. And this might look familiar to you. The only difference is that the y's are attached to it. Okay, so if we want to get rid of this entire term, the 3 and the y, I know they're multiplying each other. I can just say, well, it's a positive 3, so we need to subtract 3y and do it to both sides of the equation to keep it balanced. And now we would be left with the two-step equation. Now, generally what happens is when I teach this, someone goes, well, Mr. Tate, why don't we just divide it by 3? Because the 3 is multiplying the y. Well, ask yourself this. If I divide it by just 3, right, this y has always been left sitting there. And we still have the 10y over on this side. And in fact, we'd have the other added difficulty of having to divide all of this by 3 also. And so that would be a huge pain. So we can divide by 3, but it's not going to do what we want it to do, and that's to basically make this 3y disappear. And we want to take it and somehow get its remnants over here to the left side of the equation. That way, we'd have all of the y's on one side of the equation. So what we do is we literally think of it as terms. Again, we would think of this as a positive 3y, and that lets us subtract 3y from it. Now, since this has a term with a y on it, we're just going to subtract from the term over here that has a y on it, so we can go ahead and combine like terms, basically. 10y minus 3y is 7y. Our plus 6 term falls straight down. Our equal sign falls straight down. Again, all of this went away, which is what we wanted to have happen. And then the minus 1 falls down as a negative 1 right here. It just falls right in place. And here is the equation that we need to solve now. So the 7y falls down. Careful with this one. It's not negative 5. It's actually negative 7. And so y would equal negative 1. What do we do when we see something like this? It's almost overwhelming the first time that you see it, but basically we go through and we get rid of our parentheses first, just like we always have. Pay careful attention to the signs to make sure that we don't have any issues. And so all of this has gone away and everything else just drops straight down. Now, before we do anything else, let's go ahead and combine anything that we can on the left side of the equation. And we'll do the same to the right side in just a second. Negative 4p can be combined with negative 8p. So negative 4 minus 8 is the same as negative 12. That minus 16 can't be combined with anything else. And this 16 can't be combined with anything on this right side of the equation. I'm just trying to see, is there anything I can combine the 16 with over here on the right side of the equation? It can't, so it comes down. And the same thing's happening with this negative 8p. I can't combine that with anything else because, well, this doesn't have a p on it, so this just falls down also. But if I had something like this, if there was 16 minus 8p plus 2, I would go 16 plus 2 would make this an 18. But again, this plus 2 never existed there. Now, we have both sides simplified as far as we can go, but I do have a p on this right side of the equation. So I look at the term and I go, you know what? Let's just add 8p, draw my line. Let's box this up to show that it's going to cancel out. And now I have to do plus 8p on this side. And because it has a p on it, I'm going to line it up right underneath my other term that has a p right here. Negative 12 plus 8 is negative 4p. And everything else just drops down, and we're left with a two-step equation. Last one. There's no distribution on this left side. It's actually on the right side. We don't care where it shows up. We're just going to take care of it. Same way that you always have. So all of this became 4 plus 12n. It's just it's on the right side of the equal sign, and everything else just drops down. Now, is there anything I can combine right here? No. Anything I can combine right here? No. So let's get all of our variables to one side of the equation. I'm just a traditionalist. I like getting the variable to the left side of the equal sign. So let's just go ahead and subtract 12n from both sides. This negative 12 is not involved, so we'll drop that straight down. 4n minus 12 is negative 8n, so I'll just write minus 8n. Equal sign drops down. The 4 can drop straight down. And 12 minus 12, well, that makes that go away. Two-step equations, all that we have left now.